Okay, we've got one more company. We're going to pivot a little bit, still in the health tech track. This is in response to a COVID-19 mitigation topic call that we had several years ago, and specifically standoff detection. Remember how well that thermal gun worked when you went into workspaces? And I don't know if anybody ever got flagged for that. So this technology is hyperspectral imaging. They use AI-enabled software to be able to measure somebody's breath as they breathe, and then it matches it with a library, and then is able to, it's not a diagnostic tool, but it can say, hey, it looks like you have the COVID virus, or future viruses potentially. And so then you would go to a medical person and verify that whether you have that or not. So they've done a lot of testing. It looks like it's got applications in other areas: food safety, agriculture, potentially livestock, being able to maybe tell if a cow has mad cow disease. So there's a lot of possibilities for this technology. So Al League, come on up. He's the Chief Technology for EnSenSys.
Thanks, Ron. Good morning, everybody. Last year I got to follow a dog demonstration. It was fantastic. This year, I'm the last person between you and lunch. What's going on there? But anyway, so hyperspectral imagery, what is that? Okay, weird science, right? Former national security guy and guys and gals. Okay, but about a week or so ago, we had a unique phenomenology. We looked up at the sky at night and we saw greens and reds, clouds of energy in the sky. Think about that as a breath cloud. And how did you reference where to look? You knew the North Star, you knew the Big Dipper, Orion's Belt, those constellations. Those constellations are signatures that navigators discovered the New World as they came from Portugal in the 1500s. Those constellations are the signatures of a COVID virus in a breath cloud in a hyperspectral imager that's sitting right upstairs that you're welcome to try out today. Not with your breath, however. I do not have FDA approval to do that, but I'll show you how to do it. Similarly, another version of that can collect the breath of a cow in a squeeze pen when it's going through a medical evaluation. And I thought 10 seconds would be an incredible opportunity. If we could look at a breath in 10 seconds and say, that person potentially has COVID, or that person has RSV, or you have a common cold, or you are awesome, come into my party, let's rock and roll, that would be great. 1.3 seconds is how long it takes in a local computer. And it can be networked together into a cloud environment so that those threats are constantly evaluated and refined. Let's look at it a little further. Oh, there I am right there. So on the top, you see something I shared with you last year. This is the medical configuration of the system that SVIP sponsored us to invent. We assembled commercial off-the-shelf technologies into a capability in very short order. We've gone from TRL-1 to TRL-7. We're ready to go to larger production if we are challenged with a purchase order or additional investment. And we're now, matter of fact, we just pulled the sensor to bring it here out of the University of Maryland Emergency Center in Baltimore, where we captured breaths and from subjects who had volunteered who had positive COVID, RSV, influenza. Similarly, during the times when we weren't using the sensors in the hospital, we sanitized it. We always sanitize, we move it around. We took it to 2 facilities in Tennessee where we were evaluating the health of cattle as they were going in transshipment from one owner to another, moving from their calving to their feedlots. And found a remarkable number of them had a plethora of diseases that current veterinary protocol did not catch. And they were at risk at infecting entire herds. In fact, Mr. James Bugg's with us today. He helped work with the veterinarians in Tennessee, and they are literally changing the protocol about how our beef cattle are moving to us in the stores based on this experiment that was sponsored by SVIP. So a massive, massive change to our food security is on the horizon. Why is that important? Ladies and gentlemen, I'm in national security. It's my job to tell the national decision makers what's going on. Avian flu has transmuted to the mammal population. It is in dairy cows in 12 states now, okay? And in raw milk, if you come in contact with that raw milk, you can contract avian flu. It's real and it's coming. These technologies and some of the other technologies that we heard about this morning can be the tripwires, can be the indicators to stop the next pandemic, and that's really what we're here talking about today. Okay. So how is ESS Protect going to do this, right? Well, we want to work with large systems integrators. I don't want to build the 30 to 50,000 units that the market opportunity is. I want to license this design and technology to medical manufacturers, and we have some initial limited run production capabilities, begun negotiations. And frankly, I'm not a medical personnel, and I don't want to put a legion of people out there in scrubs with mass testing people. We want to distribute these capabilities to veterinarians, to healthcare facilities when we get through FDA approval, a very long path, by the way, ladies and gentlemen, and also initiatives for CBRE, because it turns out that if somebody had a bad idea, like releasing a cloud of fentanyl over a festival with a drone or something, it might take a little while to figure out what's going on, but that signature would flip down in front of one of our sensors and immediately be setting off the, I've got fentanyl, I've got this, or I've got that. And I don't need to build a new sensor for every potential threat. I just upload the new signature to the local, and then it can report to the cloud. And by the way, we are HIPAA and CUI certified. We use NSA plus encryption in all of our data files, and have had to pass multiple IRBs at all the medical institutions, so we are completely compliant in that. But the real model here for ESS Protect is those signatures, the library of those signatures, and continuing to evolve that through distribution of the systems and then reporting back threats. But we're not only interested in threats, we're also interested in the cow that does not have any disease in the herd that does. What is unique about that cow? Has it got a specific set of genomic structure that allows it to be resistant? And can that genomic structure be replicated in order to breed stronger strains in our food supply?
Yeah, and there you go. You're over time, so we'll get to the
I was just done, so I was going to ask you for your questions. The system is upstairs, and we're happy to show you how it works, and we'll also show you the new deployable version, which the code was developed by, believe this or not, a brilliant junior high school student who's with us today, Miss Ashta Dozy. She's here. She's from Thomas Jefferson High School here, and she works with us as an intern, and she is the next generation because I've got gray hair, and we got to pass it on to somebody because this is a technology for the future.
What's the range?
The range of the sensor as it's currently configured is about 60 inches because it was designed for a medical situation where we roll it up next to a treatment bed, and it's purposely built at a location so that if a person's sitting at 45-degree angle, it takes a picture of their breath, not their face, but we just image their breath. But in its drone configuration, we can fly at 25 meters.
Okay, what about walk-by speed? And so if you're walking into a federal building and you're going to put this somewhere,
in that configuration, it's designed to be, if you want to do individual screening, then we do need a stop and exhale, and then we cleanse the air before the next person enters that space. The original design was actually a TSA body scanning booth and adding this to it.
Could you do us all a favor and put in an alert for bad breath? That would really save a lot of us.
Yeah, let's get a signature for halitosis.
I'm just
right?
asking,
yeah, absolutely.
halitosis.
Yeah.
Just similar question, but how do you get ahead of, particularly with COVID, but the politicization of the diagnosis, right, and the all of it? You know, I think the animal application absolutely makes sense to me. The human application in the government workforce I see is a little bit more bumpy. So I'm curious what your thoughts are.
It's very bumpy, and that's where we thought we were going to go in 2020 and then 2021 when Melissa sponsored us. We actually thought that we could put these sensors at building locations, and those folks would be saying, hey, please go to some medical screening. I'm going to tell you, I'm an intel officer by trade. I don't make policy. I provide information to policy decision makers. I'm happy to guide them in the application of this, but it is designed so it could be modular, and so another additional application was, okay, so suppose we did tie it into DHS, and Daryl actually said, what if we tied it in to the DHS badging system? Well, in that case, the instantiation would be a completely proprietary system and totally internal to DHS and its personnel policies. Similar for an Amazon warehouse, right? Amazon wants to tell their worker to go home or come in or go to lunch or go take this pill. That's up to Amazon. I'm only providing the capability to understand the threat and mitigate it to reduce the risk to our society.
So I know you talked a little bit about adding a new signature is very easy. Do you need to have the signatures in place to have a detection, or can you do an anomaly detection that says, hey, this is something new, we don't recognize exactly what it is, but it's new?
That was actually the initial thought was, okay, somebody comes, or a cow, let's use that example, comes through the squeeze chute and is showing symptoms, but the PCR doesn't show anything. So that is an anomalous signature. We're going to pull that one back and do a lot of more analysis on that with our imagery analysts and turning on some AI. And also, by the way, but at the same time, compounding a vaccine against what we've discovered, right? So it can be deployed rapidly. But yeah, so we're looking for that. And then one of the reasons for the concept behind networking this together is this a unique signature? We've only caught it one time? Or is there a unique signature showing up in multiple regions? And now, what are the vectors that are causing that to coalesce, right, to mitigate the potential of an outbreak?
Got it. So I'm assuming then you have access to all the data from your systems as it's coming in so that you can kind of analyze across.
In the research and development that we've done to date, yes, that is the case. However, each implementation is going to be unique to the user and their requirements. But the design, the negotiated design would be, and it would be in their best interest, to provide those back to us. Now, I would say that when we get them, they are de-identified. It's just a signature.
And sorry, one other question.
Sure.
Is your system a dry system, or does it require, like, what are the requirements necessary to kind of keep the system up to date? Do you need to partner with, like, labs and have, some sort of, like, what
So
does
the
system
signatures
require?
come back, and our spectral scientists evaluate them against known references that we have. And we then are using machine learning to spawn multiple thousands of these images to then train the machines to look for them. But the image can the system can run standalone. It can run solar powered. It can run battery powered. It can run in the field. Doesn't matter. Can run network connected. Doesn't have to run network connected. Matter of fact, in the hospitals, we do not run it network connected doing clinical trials, but we do retrieve the de-identified data on a daily basis and then push that back for additional analysis and see how it's tracking with the existing signature, or is the signature mutating and migrating. Thank you very much. Privileged to be part of this program. Thank you, Ron. Thank you.
Thanks, Al. Okay, please give a hand to all our presenters and our panel. Thank you very much. Thanks a lot.
Thank you, sir.
You guys are excused. Thanks, great questions. Okay, nice try, Al. We're not at lunch. We're going to do a break, even though my stomach is growling. So we're going to take a 15-minute break. Be back at 11:15, please.
Shake it, shake it, shake it, shake it, shake it.